All right, today in class we talked about ratio tables. And before we started class, I talked about how to find my markups on your mid-chapter check. So if you want to make corrections on that assessment, you have a week to do that. You just need to do it in another color. And then when you submit it, you're going to write a sentence explaining your mistake, or sentences if you made more than one mistake, and how you fixed it. If you have questions on quiz corrections, you can come to see me during WIN. All right, we're going to be taking notes in our book today. So you're going to turn your book to page 39. So pause this video if you are not there and get to page 39. All right, so in this problem, it says a punch recipe uses 1 container of soda and 3 containers of juice. Okay, so if I make one recipe, it uses 1 soda and 3 juice containers. Okay, below it wanted us to use red counters to show the number of containers of soda and draw yellow counters to show the number of containers of juice. In class, we just used S's and J's to show how much is needed for 2 batches. Okay, so you should be doing this along with me. 1 batch is a soda and 3 juices. So if I make 2 batches of the punch, I'm doubling my recipe. I need another soda and 3 juices. Okay, so when I count the sodas and the juices, I see 2 sodas and 6 juices. So in my doubled batch, it is a ratio of 2 to 6. In the next problem on page 39, it wanted us to make 3 batches of the punch. Okay, so if I have 1 soda in 1 batch, I need to triple it. So I will have 3 sodas. And then I have 3 juice containers in each batch. Okay, so when I count them, I have 3 sodas and 9 juices. It says find the ratio in simplest form. So in the first batch I made, it was 1 soda to 3 juices. When I doubled it, it was 2 soda containers to 3 juice containers. And now here I found it for 3 batches. If I simplify those, oops, sorry, that was supposed to say 2 to 6. That was my mistake. If I simplify those, so I can divide this one by 2, I get 1 to 3. I can divide this one by 3, and I get 1 to 3. It always simplifies down to a ratio of 1 to 3. Okay, so we might notice that 1 to 3 is the same thing as 2 to 6, is the same thing as 3 to 9. Those are equivalent ratios. So this information can be shown in a ratio table as well. So for example, I know that 1 soda used 3 juices, 2 sodas had to go with 6 juice containers, 3 containers of soda had to go with 9 juice containers. Okay, a ratio table is a table that has columns filled with pairs of numbers that have the same ratio. So if I simplify any of those, the 2 to 6, the 3 to 9, I could go on. If I add another soda and another 3 juices, it's 12. All of those can be simplified down to a ratio of 1 to 3. And in class, I challenged people to come up with answers to more difficult ones. So for example, we jumped to 5. And people did this a couple different ways. Some people figured out that you could keep counting. So if you did like a 4 to 12 and then a 5 to 15, so some kept counting. That's one way. Some jumped. So if you're at 3 sodas, you can multiply the sodas by, or sorry, nope, I'm thinking of a different part. 1 soda, you're multiplying by 5. If I'm multiplying it by 5, I also have to multiply the juices by 5. Okay. Another strategy that we came up with was noticing that the soda multiplies by 3 every time to get to the juices. So this would be a times 3 as well. Okay, so there's many different strategies you can use. Okay, I then challenged the class to go all the way up to 15 sodas. So what if we had 15 sodas? How many juices would we need to go with it? Some people started at the 3 and multiplied by 5. And then you would have to multiply the soda by 5. Some people started at the 1 soda and multiplied it by 15. So using the unit rate and multiplying by 15. Okay, other people noticed that, remember, it's always a times 3. So there's a couple different strategies that were being used in class. Okay, let's look at some examples. So on page 40, we had an example. To make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. So that's shown in the table here. 6 drops of yellow food coloring, 1 cup of icing. The question is asking, how much yellow food coloring should you mix with 5 cups of icing? So the same thing as what we did before. If we want to go from 1 cup of icing to 5 cups of icing, you would need to multiply by 5. You're multiplying that recipe by 5. If I add all that icing and I don't add enough yellow, my color is going to be too light. Okay, so I also need to multiply the drops of yellow by 5. So add 30 drops of yellow food coloring to 5 cups of icing. Let's look at another example. Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. That's shown in the table here, 66 hot dogs in 12 minutes. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. Okay, so this person knew that they had to get all the way to 2 minutes. We're trying to figure out how many hot dogs Joey Chestnut eats in 2 minutes. Instead of jumping all the way from 12 to 2, they first decided that looking at those numbers, you can tell that 66 and 12 can both be divided by 2. So this person decided, I'm going to cut my answers in half first. I'm going to divide by 2 first. And they found out that he eats 33 hot dogs in 6 minutes. Once they got that answer, they figured out that in order to get from 6 minutes to 2 minutes, they just need to divide by 3. If you divide on the bottom, you need to divide on the top as well. That is how we're making our ratio stay equivalent. We're keeping that rate the same. So 33 divided by 3 is 11. Now some of you might notice that you can also just jump from 12 all the way to 2 by dividing by 6. If I divide by 6 on the bottom, I have to divide by 6 on the top. And I could have skipped this row altogether. When you get to your homework, if you don't want to use all the rows, you don't have to. All right, I want you to pause the video and see if you can try on page 40, the got it on the bottom of the page, A and B. So the first one says, a patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take for 4 liters of IV fluids? And the second one is a cranberry jam recipe that's 12 cups of sugar and 16 cups of cranberry. But they want to make a smaller version of the recipe. They want only 4 cups of cranberries. So how much sugar will they have? So pause the video and see if you can figure this out on your own before I go over it. All right, we're going to go over that first one now. So if you have 1 liter of fluids, it takes 8 hours for that to go into your body. If we are going to 4 liters, we need to multiply the amount of fluids that are going into the body by 4. If the fluids are multiplying by 4, then the time is going to multiply by 4 as well. So we need to do the same thing on the bottom. And we will get an answer of 32. Some of you may have also noticed that this is multiplying by 8. So you can do the same thing here and get the answer of 32 as well. If it's more helpful to you, you can make your own table. And you might notice, okay, it's a 1 to 8, so then it's a 2 to 16. We're doubling both. You could count the pattern out like this, if that is easier for you as well. Let's look at the cranberry one. Cranberry jam is 12 cups of sugar, 16 cups of cranberries. We want to get down to 4. A few of you in the class might know how to get right down to 4. That might be obvious to you. Others of us might want to do something different. Maybe divide by 2 to start with. Cut it in half. So 6 cups of sugar uses 8 cups of cranberries. Okay, and then we would cut it in half again. Divide by 2 again. 3 cups of sugar for 4 cups of cranberries. And again, you may have skipped some of that middle box and just divided by 4 right from the beginning. And that is a possibility as well. All right, so when you multiply or divide by the same number, it's called scaling. So when we were looking at the table and we were multiplying by, let's say 2 on the top and multiplying by 2 on the bottom, that is called scaling. So we're scaling forward or scaling back. Scaling forward is when you're going bigger, and scaling back is when it's getting smaller. We're going to skip ahead a little bit. So an example where you might want to scale back and then forward is an example like this. It says a child's height is 105 centimeters. Estimate her height in inches. So I know from the table that 25 centimeters is about the same as 10 inches. This one is challenging because I can't go from 25 to 100. There's nothing I can multiply there. Even if I double this 25 and I do a times 2, I get to 50. But 50 can't get me to 105 either. So I can't use multiplication at all. So the strategy that I'm going to use is I'm going to scale back first. I know that both 25 and 10 can be divided by 5 because they both end in a 5 or a 0. So I'm going to get to a small number and then see if I can get to 105. 25 divided by 5 is 5. And 10 divided by 5 is 2. Now, is there a way for me to get all the way from 5 to 105? Well, this ends in a 5, so I must be able to count by 5s. So I'm going to count my 5s, 5, 10, 15, all the way up to 105. And I know that I can do 21 of them. If I multiply something on the top of the table, I have to multiply it on the bottom as well. And 2 times 21 is 42. Okay, so that is something you might have to do. You might have to divide first and then multiply. Okay? For your homework, you're going to decide if you're going to do near mastery, mastery, or exceeding mastery today. All of the homework begins on page 43. Depending on the problems you choose, you might have to do some on some other pages. So look at the table. This is also in the ratio table, book practice on Canvas. Or you can take a screenshot of this so that you know what problems to complete. Let me know if you have questions.